This is the worked answer to the unit test 8 question 4. In this question we have a car of mass 1200 kilograms and a trailer of mass 400 kilograms. They are connected by a tow rope which is modelled as light and an extendable rod. The fact it is light means we can ignore the weight of the tow rope. The fact it's extendable is it means that the thing attached to this end and this end are moving at the same speed and same acceleration. In fact, that is the answer to part D. The engine of the car is providing a constant driving force of 3,200 newtons. The horizontal resistance of the car and the trailer are proportional to their respective masses. So what that means is we currently have a ratio of 3 to 1 car to trailer, so that means the resistance will be 3 to 1 in terms of the car and the trailer. We are finally told the acceleration of the car and the trailer is 0.4 meters per second. We're asked to find the resistance to the motion of the trailer, the tension in the tow rope. So I'm going to answer A and B first and then come back to do part C. So in part A we're going to want to draw our car and trailer, and we're going to put our masses of 400 kilograms and 1200 kilograms. They are attached by a rope. That rope is going to be pulling the trailer forwards and it's going to be slowing the car down, so pulling it that way. And I'm going to call this T. There is a driving force which is going to go this way at 3,200, and we have a resistive force coming this way which I'm going to call R1, and a resistive force here which I'm going to call R2. Remember that R1 will be 3 times bigger than R2. Right, now I'm going to take advantage of an idea to save me having to do simultaneous equations. What I'm going to do is I'm going to make this string, or the rope even, infinitely small. I'll make it smaller and smaller and smaller, and hopefully you can see you'll end up with one particle which is 1,600 kilograms. We're going to have a force coming this way of 3,200, and then we're going to have an R total going this way. So R total is R1 plus R2. What this means is that I can now use F equals MA. I forgot one key piece of information which told us that the car was accelerating in this direction 0.4. So that means the whole system is accelerating in this direction at 0.4. That was important for this part of the question because I now needed to decide, so I could work out the resultant force. What's bigger? Clearly this one is bigger because it's accelerating in that direction. So 3,200 minus R total, I'm just going to put RT, is equal to MA, 1,600 times 0.4. So 3,200 minus RT equals 640, and that will simplify to give us RT is 2,560. I'm going to split this into the ratio of 1 to 3, which means that I get 640 to 1920. So that tells me that R1 equals 640 newtons. In part B, I can no longer keep the model as 1 because I'm trying to work out the tension in the tow rope. I could work out this tension or I could work out this tension. They are going to be equal and opposite. So what I'm going to do is I'm going to split the car in half, or split the rope in half, and I can either work on this side or this side. It makes sense to work on this one because you only have 2 forces. If you were to work on this one, you'd have to deal with 3 forces. So I'm just going to draw the part of the model that I'm using. So this is 400, pulling this way is tension, pulling this way is R1, but I know R1 is 640, so I'm going to use the 640. It's still accelerating in this direction, so that tells me T is bigger than 640, so T minus 640 equals 400 times 0.4. So T, that times that is 160, so 160 plus the 640, T equals 800. Going back to the question, I know that should have being newtons, because it's tension. Similarly, I'm just going to double underline that to make it really clear. Going back to the question, when the car is travelling at 25 meters per second, the tow rope breaks. So what that means is they're no longer connected. The resistances are unchanged. We want to work out the trailer. When does the distance? What is the distance the trailer travels before coming to a stop? So I'm going to carry on using this idea of just looking at the trailer. So I have a trailer which is 400 kilograms, and we have a force of this way of 640. The acceleration, it's clearly not going to be accelerating in that direction anymore. It's now going to accelerate in this direction. So I need to work out that acceleration. So I can use force 640 equals 400A, divide by this, and I get 1.6 equals A. That tells me that the acceleration is 1.6 in that direction, and we also knew from the question that it's travelling in this direction of 25. Notice I use one arrow for velocity, and I use a double arrow for acceleration, so this should make it extremely clear what's going on. I'm then going to use SUVATs, so S-U-V-A-T. S is unknown and is what I'm trying to work out. U is 25 because that's the speed when the rope snaps. I'm trying to find out when it comes to rest, so it will finish at 0. Acceleration is 1.6. You need to be careful. The 1.6 is in the opposite direction to the 25, so it's going to be minus 1.6. And T I don't need to worry about. Equation linking S, U, V and A. V squared equals U squared plus 2AS. Some people will substitute these values into here now. Some people will do it afterwards. I'm going to do it afterwards. So V squared minus U squared over 2A is equal to S. So we're just making the variable we're trying to find the subject. Now I can substitute into this. So 0 squared minus 25 squared over 2 lots of minus 1.6 equals S. And now we can see the top will be negative, the bottom will be negative. Negative divided by negative will in fact give me a positive, and it gives me S equals 195.31 meters. And I've left my answer to 2 decimal places because, like money, typically we use meter to be 100 centimeters, so giving it to 2 decimal places seems to make sense. Part D has already been answered, so that is the end of that question.